Now, if I want to attach this serine to this, where do I attach? Remember, it's always OH, right? Now, if you want to draw phosphatidyl ethanolamine, first question you should ask yourself is, phosphatidyl ethanolamine is made up of what? So we'll be talking about phospholipids. Phospholipids. And from the word phospholipids, you can see that phosphate, phosphoric acid, is attached to lipids, right? Good. Now, it means phospholipids are composed of the simple lipids and phosphoric acid attached, right? So here we can be having simple lipids are composed of two things. What and what? Fatty acid and what? Alcohol, right? Fatty acid plus alcohol. Now, if the alcohol present is glycerol, then the phospholipid will be what? Glycerophospholipid, right? But if the alcohol present is sphingosine, we have what? Sphingophospholipid. Good. So first we are going to be looking at the glycerophospholipid. So it means glycerophospholipid contains fatty acid, glycerol, and phosphoric acid, right? But most of the times, in addition to the phosphoric acid, there is always a base attached. So most times glycerophospholipids have fatty acids, glycerol, what else? Phosphoric acid, plus a base, right? Good. So fatty acid, glycerol, phosphoric acid, and a base. Now, the examples of glycerophospholipids, we are going to see them and we are going to know how to draw all of them. The examples of glycerophospholipids are 1. Phosphatidic acid. This phosphatidic acid is the simplest. And this phosphatidic acid contains only 3 things. Who can tell me? Contains 3 things. What and what? Fatty acid, glycerol, and what? Phosphoric acid, right? So it contains only fatty acid, glycerol, and phosphoric acid. It means there's no base attached to the phosphoric acid, right? Good. Now, phosphatidylcholine. Phosphatidylcholine contains fatty acid, what else? Glycerol, phosphoric acid, plus what? A base called what? Choline. Do you understand? This one, only fatty acid, glycerol, and phosphoric acid, no base. But this one, phosphatidylcholine, contains fatty acid, glycerol, which is a simple lipid now, phosphoric acid, and choline. So, another name for phosphatidylcholine is what? You call it what? Lecithin. So if you don't call it phosphatidylcholine, you call it lecithin. Now, phosphatidylethanol-amine. Phosphatidylethanol-amine contains what, and what? Fatty acid, glycerol, phosphoric acid, and what? Ethanol-amine. So the base here is ethanol-amine. Are you following? If you don't call it phosphatidylethanol-amine, you call it what? You call it cephalin. If you don't call it phosphatidylcholine, you call it what? Lecithin. Good. Now, phosphatidylserine contains what, and what? Fatty acid, glycerol, phosphoric acid, and what? Serine. Same thing applies to all these ones. The bases are shown here. Inositol, glycerol, then diphosphatidylglycerol. It's like you are putting 2 phosphatidylglycerol together to form this. All right. So we are going to learn how to draw them now. So, but before then, let's know how to draw generally glycerophospholipids. Can I clean this? All right. So let's draw. We'll be drawing them one after the other, and they are very simple to draw. So just listen up. I'll give you time to draw. So for now, just stop writing and listen up. Glycerophospholipid. So we already know that glycerophospholipid contains the alcohol what? Glycerol, right? So the first thing, let's draw glycerol. Glycerol have how many carbons? 3 carbons, right? 1, 2, 3. And all the carbons have hydroxy group. So OH, OH, OH. Then you balance your tetravalency of carbon. H2, H, H2. This is the structure of our glycerol. Now, glycerophospholipid, one thing you should note is that in glycerophospholipids, carbon 1 and carbon 2, we always have fatty acids attached to carbon 1 and carbon what? Carbon 2. Then the phosphate group, remember we are talking about glycerophospholipids, right? Carbon 1 and carbon 2, we normally attach what? Fatty acid. Then carbon 2, we attach what? The phosphate group, the phosphoric acid. So on this carbon 1, yeah, we want to attach our fatty acid. And you agree with me that the general formula of fatty acid is, right? COOH, right? ROCOOH. Now, if I turn this thing like this, have I changed anything? I did not change anything. I just flipped it like this. Good. So now, if I bring this one here, is this still a fatty acid? This is a fatty acid, right? Now, condensation will take place between the OH of the glycerol and OH of the fatty acid. And you know, in condensation reaction, water is given off, right? So water is H2O, right? Or HOH. So this whole stuff here will be going out, right? Water is going out. Then bond is formed. The same thing happened to this second one. I've attached fatty acid on carbon 1 and fatty acid on carbon 2, right? If I leave this compound like this, how will you name it? What is this compound called? What is this compound called? Diacylglycerol. If I attach only one acyl group, only one fatty acid, you call it what? Monoacylglycerol. If I attach two, call it what? Diacylglycerol. Now, if on position 3, I attach a phosphoric acid, this is how phosphoric acid is. This phosphoric acid attached. What I now have now is what? What is this structure called? This is a glycerophospholipid, right? But this is the simplest form we can have because there's no base attached. So this structure on the board is called what? Phosphatidic acid. This is the structure of phosphatidic acid. So as you can see, it has glycerol, 2 fatty acids. We are just using arrow because we don't know the specific fatty acid now. Then the phosphate group attached. Do you understand? Phosphoric acid is H3PO4, which is same thing as writing it this way. If you count, how many hydrogen do we have? 1, 2, 3, right? H3. We have just 1 P. And how many O? 1, 2, 3, 4. So this now, we now condense. Okay, now look at this. Here was OH, right? Is it not? Condensation will still take place. H with OH to form out water, and we'll have our remaining parts formed here. So this structure we have on the board now is now phosphatidic acid. Do we get that? All right, so let's look up. We've seen how we can draw phosphatidic acid. Now let's draw phosphatidyl ethanol amine. But you know, if you want to draw phosphatidyl ethanol amine is also called what? It's also called what? Cephalene, right? It's also called cephalene. So in case you are asked to draw cephalene, it's still phosphatidyl ethanol amine. Now, if you want to draw phosphatidyl ethanol amine, the first question you should ask yourself is, phosphatidyl ethanol amine is made up of what, and what? So first, the alcohol is what? Glycerol, right? Plus, we'll have fatty acid, right? And you know the fatty acid will be on carbon 1 and carbon 2. Then from fatty acid, we have what? Phosphoric acid, right? And then we have a base, what? Ethanolamine. So we want to see how we can draw all these things and put them together. First, let's draw our glycerol. Glycerol is how many carbon? 3 carbon, right? And all the carbons have OH, right? Then you balance of H2, H2, right? Now next, fatty acid will be attached, right? And I've shown you how to attach fatty acid. So fatty acid will be attached on carbon what and what? 1 and 2. So if you attach your fatty acid here, you have this. If you attach the second one, you have this. Then on the third carbon, what do you have there instead? Phosphoric acid, right? We are making progress. We've done this, and now phosphoric acid. So phosphoric acid, these are phosphoric acid, right? Good. If I leave this structure like this, which structure is this? Phosphatidic acid, right? The simplest one. But now what I want to draw is phosphatidyl ethanolamine, meaning I have to attach the base, ethanolamine, right? So at this point here, please listen up your jaw. At this point here, you attach ethanolamine, right? Is it not? You are attaching it to the phosphate group, right? Good. But you're not just going to write ethanolamine here. You're going to draw the structure of ethanolamine here. And it's very easy. Now look at this. Ethanol have how many carbon? Ethanolamine, you are hearing ethanolamine. Is it not? Ethanol. What's the formula for ethanol? CH3, CH2, OH, right? This ethanol, right? Then they say ethanolamine, meaning you are adding amino group to ethanol, right? And amino group is NH2, is it not? So I'll attach NH2 here. This is my ethanolamine. This is the structure of ethanolamine. Now I want to attach this ethanolamine to this. Now if I turn this structure this way, have I changed anything? I've not changed anything, right? I just flipped it. Now if this thing condenses with this, H will take OH, right? And water will be going out, is it not? So water is going out, condensation, and these bonds join to this. This is my phosphatidyl ethanolamine. This is phosphatidyl ethanolamine. I must also point out, listen up, I must also point out that this ethanolamine, you can see it like this also. NH3 plus in the ionized form, you've not changed anything. Instead of NH2, you can use NH3 plus. They are the same thing. This is in the ionized form. So this is phosphatidyl ethanolamine. So draw that, and we'll draw the next one, phosphatidylcholine. So let's see how we can draw phosphatidylcholine. We've drawn phosphatidyl ethanolamine. Now phosphatidylcholine. Now phosphatidylcholine. So if you want to draw phosphatidylcholine, you agree with me that phosphatidylcholine is made up of glycerol, fatty acid, phosphoric acid, and what? What's the head group? Choline, right? So choline. Now, the structure still remains the same. Please, I'll give you time to draw, so listen up. The structure still remains the same. But see the difference here. We already have our glycerol, right? Fatty acid on carbon 1 and 2. Phosphoric acid on carbon 3. Then here is where we have to attach our head group, right? Now, look up. I want to ask you a question now. If we have something like this, which structure is this? This structure on the board is what? Is this ethanolamine? No, phosphatidine what? Ethanolamine, right? This is phosphatidine ethanolamine. Remember I said you can use NH2 or NH3 plus, right? Now, for you to convert ethanolamine to choline, how many hydrogen do we have here? 3, right? Change all these 3 hydrogen to methyl group. So instead of H3 here, we'll be having 3CH3. That is, instead of 3 hydrogen, you're having 3 methyl. This is a methyl group, right? So you're having 3 methyl group instead. Do you understand? So the difference between ethanolamine and choline is that instead of having, now check this. You know, if I want to put this, split out this hydrogen, I can do it this way. H, 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 right? 3 of them, right? But in choline, I'll be having here CH3, 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 and since we've overloaded nitrogen, we'll put plus there. So the difference between ethanolamine and choline is instead of 3 hydrogen, we'll put what? 3 methyl group, right? So at this point here, what we now have is what? This structure on the body is phosphatidine what? Choline. Let's see how we can draw phosphatidine serine. Phosphatidine serine. Now, in phosphatidine serine, the only thing that will change here is that the head group becomes what? Serine, right? The head group becomes serine. Now, it means this head group has changed, right? This is the only thing changing now, the head group, is it not? Good. Now, serine is an amino acid, right? Serine is an amino acid, is it not? And you're supposed to know the 20 standard amino acids. Their names, their 3-letter code, their 1-letter code, and their structures. So you're supposed to know the structures of the 20 amino acids. I'll teach you that. But for now, the structure of serine is this. This is the general structure of amino acids, right? Is it not? This is the general structure of amino acid. Serine has just CH2OH. This serine. This serine. I want you to look up very well. Stop writing. I'll give you time to write. Look up very well. What is the difference between this serine and ethanolamine? Look at it very well. Look at it critically. What's the difference between this serine and ethanolamine? Carboxylic acid group, right? Because this is ethanolamine. So like this here. This is ethanolamine, right? Only this CH. Forget about the number of hydrogen present. Because hydrogen, we are just using it to complete the tetravalency. So 1, 2, 3. This is ethanol, right? This ethanol, is it not? If I add amino group, this ethanolamine, right, which is same thing as this, then I now add carboxylic acid group, right? Yes. So now if I want to attach this serine to this, where do I attach? Remember, it's always OH to OH, right? OH to OH. So this OH and this OH, remember, one H will be taking OH to form water out, right? Look up. So this is taking this OH. So the bond is connected to what? CH2, right? So I have CH2 here. Next to what? CH, right? And on the CH, we have NH2. And still on that CH, we have COOH, right? This is phosphatidine serine. This is phosphatidine serine. So if you remove this, you see that what you just have here is phosphatidine ethanolamine. If you carboxylate it, if you add carboxylic acid group, you have what? Phosphatidine what? Serine. So this is the structure of phosphatidine serine.